Hey everybody, welcome back. This is the objects lesson in the objects unit of module 0. And looking at this, I probably should have changed objects unit to something like collections because that's what arrays and objects both are. But arrays and objects are also both objects, so we're kind of stuck in the middle there. Anyway, here's the video walkthrough of where this is going to go. And so what is an object? An object is a collection of properties. Properties have keys and values. Sometimes those values are functions, and in those cases we could refer to that function as a method. And loosely. There's people who complain about that because it's not precisely a method, and why they do that is not really important for us. But what is what we've said so far. Object is a collection of properties. Properties have keys and values. So we're going to have a quick glance at a couple of objects. Same idea. We declare a variable, and we set it equal to curly braces around whatever we want our collection of properties to be. So these are the properties, these are the keys, and these are the values. So this key has this value, this key has this value, and the object overall has two properties. Same thing for an object with numbers. Now, we did Boolean, numbers, and strings, but you don't want to think about that as like, I need to put only number values in my numbers object or refer to it that way. You want to consider that for the most part an object can have values of any type and it's not really dependent on anything. I just wanted to demonstrate a couple of different ways that we could have the values. So we're not going to run this code. We're not going to run this code just because nothing's really happening. We're just defining some objects. But now that we want to access the value of a property, we are going to run this code. So we need to the name of the object. That's awkwardly phrased. So hopefully that'll look a lot better once you actually see this content live. But what we need is this one is the extra word. So we need the name of the object and the name of the key. And there's two ways to do the same thing, which is to say access the value of a property. We can use dot notation or we can use bracket notation. So the first one we're going to use is dot notation. So I'm going to grab my object, move over to replit. This is the last thing from the arrays section. I'm going to delete that and paste this in. I'm going to clear the console. So here's our strings object. Strings object's kind of a weird name for it, so let's call it pet dog. Name is Daisy, current title is Pupper, future position is Doggo. Okay. Anyway, to access the value within an object, we're going to use this expression right here, and we're going to, like we have been, assign it to a variable. We could say, and we change the name of the object, so let's go ahead and change it down here. So pet dog is the name of the object. Dot name is going to access the value of the name key, which is to say this value right here. So if we console.log accessed using dot notation the value of the name, we're going to hit run, and we should see Daisy. Excellent work. We could also change this to current title, access it that way. Value of name isn't really a good variable name for this anymore, so perhaps we'll say value of current title. And I'm going to hold down Option, I'm going to hold down Shift, and I'm going to hit the back arrow key. Now what that's going to do is it's going to highlight the word that I'm currently next to. I'm going to copy that using Command-C and paste that in. And same idea, I'm going to be able to access the value of current title using dot notation again. So dot notation is an instance where you just say dot, then list the exact name of the key that you're looking for, and it'll go through the object and look for that. Now this is actually, well, order of operations, or let's say order of the way that the language is developed isn't really that important for us, but you want to consider that this is going to essentially be interpreted as what we're about to view, which is to say dot notation more or less is the same thing as bracket notation, but slightly more limited. And that might be a little bit too tantalizing at this point, but you want to consider that dot notation and bracket notation, at least in the instances that we're going to be dealing with for this introduction, are going to be almost identical. So let's go ahead and say or strings object, and we're going to take this code and paste it on in there. So yeah, we'll get rid of all this. We're not going to change the name of the object just because it doesn't really make that much of a difference. So we have the exact same object as we previously had, and we're going to say value of name is equal to strings object with brackets, and the way that a lot of people say this is strings object at name. So you want to consider that this is the exact same thing as dot name. they do identical operations. I'm going to hit Command Z a couple times, which should undo the typing I just did. Then, and that's Z as in Z. Command Z will let you go back, just basically undo whatever you just did. So variable value of name is being assigned to the strings object at name, and I'll console.log that afterwards, and we should again get Daisy. And we're in good shape. So same idea. I meant to put in an example for empty objects, but we've had one for empty strings and empty arrays. An object, as we said, does not need to have any properties to be considered an object. In some cases, it might be useful to establish a variable as an object without adding any properties to it. So since we don't have an example, let's just write one. We'll say empty object is equal to wrap curly braces around nothing, and then we're going to console.log, if we can ever find the keys, our empty object. So if we run this, hopefully it'll just put some curly braces out. And excellent. So we've mentioned this idea for strings, arrays, and objects, and eventually we will get to what I mean by that. But for now, just keep in mind that sometimes you're going to want to establish a variable of a specific type without actually adding anything to it at the moment when you create it. So we're going to introduce two things that are going to be new. The type of issue. So a relatively useful programming tool in JavaScript is something called the Typeof Operator. Sorry about that siren. But anyway, the Typeof operator is very similar to plus, minus, multiplication, division, and modulo that we did in the numbers section, which is to say that typeof isn't a function, it's an operator. So we just list typeof and then whatever we want to get the type of, whatever we want to get the type of next to typeof, and it interprets this entire expression as being type of true, type of 9, or type of some string of characters down here. So let's go ahead and grab all of this code, and we're going to go back to the console and have a look at what it looks like. So we have type of undefined, we have type of true, type of false, type of 9, type of 4.0, and let's make that 4.7, why not? And then type of a string of characters, and then literally a type of, and then this is a string of characters. So what we're going to see is we're going to find out what happens when we apply the Typeof operator to each of these values. One for each of the scalar values that we've been up to so far. So if we hit run, we're going to see first undefined, because that's the type of undefined. Then we're going to see the type of true, which is a Boolean type. Type of false, same. 9 and 4.0, we forgot to mess that up. So let's run it again just so it's nice and consistent. As you can see, it doesn't really matter, but we get a number for 9 and 4.7. As we said previously, there isn't really like an integer or a float type the way there are in some other languages. Every number is just a number. And then type of string of characters is going to be a string. So cool. So there we go. Type of as an operator being applied to our scalar values gives us these results. And that can give us a way to elicit some information about our data rather than just looking at the data itself. It would be completely understandable to assume that this would work for arrays as well. This is not the case, however. So let's have a quick look at something that sort of breaks this pattern. We're going to say type of an array. I'm going to apply our typeof operator to an array. And then we're going to console.log type of an object and apply our typeof operator to an object. So if we run this, theoretically we should get something like array here and something like object here. We won't. In fact, we're going to get object for both, which is why we've been saying arrays are objects or arrays are list-like objects. It's because that's the way JavaScript was built, and because JavaScript is continually being built, there is a way for us to get around this issue. And the way we get around that issue is array.isArray. Excuse me. Which is, of course, a method. So if we highlight all of this, bring it back over here, is an array, and we're applying array.isArray, which is the method, and then we're going to call that on an array, and we're also going to call that on an object. So now when we console.log our statements, which is to say these strings, which are identifying the outputs, we could probably make these a little bit more descriptive, but let's just run it as is. So when we apply array.isArray to an array, like an actual array, which is to say the ordered collection of elements, which are index 0, 1, 2, 3, and then we do array.isArray on an object, which is a collection of properties, which properties have keys and values. We're going to get true when we do it to an array and false when we do it to an object. So typeof is going to work in a lot of cases, but in the event that we're trying to find out if something is an array, we want to use array.isArray. So just something to keep in the back of our minds, and let's talk about the return values for our functions. So this should very closely mirror what you've been doing in the rest of the lessons, which is to say, first, we're going to declare a function that just returns an input object. And that's the definition. Then we're going to create a variable to use in our call to the function. We're going to pass that variable as an argument to the call to the function and assign the result of that calling that function to result object. Then we're going to look at it by console.logging that result object. Once we do that, we should get, quite simply, the input object right back. So excellent work. Now we're going to do something that we've done in the previous lessons as well. Instead of returning the entire object, let's return just a value based on an input key. So by doing that, this is the way that we would access it. Name of the object, at name of the key. And when the key is a variable or a parameter, you do not want to use dot notation. Now I'll show you why in just a moment. First, we're going to run it the way that it works. Variable computer, and this is just the stuff from the computer I'm working on right now. Name of the key is going to be version. Keep in mind this has to be a string because when we're using bracket notation, we have to use a string. And then we'll say variable value at key is equal to a call to return a value with arguments of computer, the object, and name of key, which is a string we're going to use to access a value within the object. So now that we run this, we're going to see, I think, 10.14.6, and we do. Now, here's the issue. Let's say that we thought we should write object.key, because a lot of people just do. What we're going to get here is undefined. And the reason that we're going to get undefined is because there is no key here called key. Now what we could do is we could actually write in a key called key and say, this will make it work. And if we run that, we're going to get back, this will make it work. The problem is that what we've done here is then hard-coded. It doesn't allow our function to operate with any given key, as it does when we write it like object at key. If we do object at key, and at that point we wanted to get this one, all we would need to do is put the name of the key as the string key. That'll let us access it the way that it should. So let's return it back to version so that it looks all nice and crisp. And we're in good shape. Now declare a function. Oh, okay, and this is the last one where instead of operating with a parameter, we're going to create an object inside of our function and return that. So this one's pretty simple. The function doesn't take any parameters. We create a variable inside of it and then return that. Same idea down here as we've been up to previously. So let's just run it, make sure that we get the object back, and we're in good shape still. Excuse me, now we have a couple of example use cases of typeof and array.isArray. So here's a function that's basically just going to use typeof. And I hope that we're getting this across, but I'm going to say it again. These are very simple examples. You don't want to get too bogged down in the idea that like, hey, I'm not really doing anything yet, because you are. You've been running code, you've been seeing console outputs, you've been operating with functions in a rather rudimentary fashion, but you are operating with functions now. Once we start adding things like typeof, which is an operator, and things like array.isArray, which is a method, we can start to get an idea of how we might be able to make more complicated functions by applying operators and methods to either our parameters or things we create inside of the function. So for this one, we're just going to apply typeof to whatever the param is, and we've got 3 calls to it. One where the type is a number, one where the type is a string, and one where we didn't actually pass a parameter. So thinking about what's going on here is going to be rather interesting. But first, let's run it and have a look at the output. So if we run it, we're going to see that the num type was a number, the string type was a string, and our undefined type, which is to say when we don't pass something as an argument for this parameter, it automatically assigns this parameter to be undefined. So that when we say type of param, but param wasn't actually bound to an argument here, we get undefined. Just another thing to kind of keep in the back of your mind, and sort of parallels what a function does by default, which is to say a function by default returns undefined. So if you fail to define a parameter by passing an argument for it, it will be undefined by default. And one more example where we're going to go over how we might apply array.isArray inside of a function. So we're going to write a function called determine if it's an array, or determine is an array with some input. We're going to say variable is an array, and we're going to assign it to a call to array.isArray on the input parameter. Then we're going to return that newly created variable. 2, quote, test cases here where we call the function, one where the array is an array, and one where the input is not an array. Sorry, one where the input is an array, and one where the input is not an array. So if we run this, we should get affirmative true and negative, oh boy, we got an error. which is excellent news because they're kind of difficult to program into this, but so let's have a look at it. Eval machine anonymous 11. So it means line 11 has some issue in it. Console.log negative, and it's pointing at this and it's saying syntax missing a parentheses after the argument list. Now the reason you might see something like this is because when we pass arguments to a method like console.log, we need to separate them with commas. Now as it looks, we did not. There's an error here where we forgot to put a comma. I forgot to put a comma there. And so it's basically like, hey, I was supposed to see either a comma or a parentheses here, and I saw neither. You're putting another variable in there, and that's no good, so here's an error, which is basically what the eval machine is saying, were it to be speaking in rather circular reasoning. So anyway, now that we've put a comma there, we're going to hit run again, and hopefully we've sorted out the error. And we have. So affirmative is true, and that's the case where the input is an array, and negative is false, and that's the case where the input is not an array. So excellent work. Glad you got to see an error being corrected, because it's kind of difficult to put those together. But anyway, now that we come back here, you probably won't see this. I'm going to go ahead and try to get rid of that to put a comma in here. But if I leave that in here, it's because I'd like you to experience the same error. And we'll see as it goes. So now we've got 5 object challenges, and it just occurred to me that I did not reset the input for any of these. So let's go ahead and reset them all real quick. And production value could use some work here. But anyway, not that big of a deal because for the most part, we're just transplanting from the documentation above. So when we return an object, let's scroll up to a function that describes how to return an object when we inputted an object. And as you can see, we're just going to return object. We scroll back down here, and we're in good shape. Now this one, I'm going to just assume that I remember the documentation well enough. I remember that when I want a value for an object, I need to access the object at whatever the key is. And then when I've done that, I'm going to return that expression. So if I run the test on this, it's correct, and we're in good shape. So now we want to create an object, which we learned how to do. We just say whatever we want the object to be called is equal to some curly braces, and we can put some stuff in here if we want, but we don't need to. Once we've then created the object inside of our function, we're going to return that object. Looking good. Now we have that type of situation. So if we scroll back up, because we kind of forgot about how to use type of, we see that if we have an input parameter and we want to get the type of, we need to apply type of as an operator to the param in this exact fashion. So let's scroll on down here, and we'll say return type of param. Looking good. And the last thing is where we're going to follow our pseudocode to make a use case for array.isArray. So we'll say something like variable result is equal to array.isArray, and I want to apply that method to the input. Now I'm going to have saved in result either true if the input is an array, and it'll be false if the input is not an array, which is exactly what the function is asking for. So at this point, I'll simply return result, run the test to make sure that I'm correct, and I'm still correct. Okay, so a minor bamboozle. You might have noticed that unlike the previous exercises, we introduced a couple of new topics at the end of this in the form of type of and array.isArray. Now, type of, as we discussed, is an operator, which means that we don't really pass anything to it. It's just something that you would list next to something that we would call an operand, which is actually this, and it allows us to, rather than dealing directly with param, deal with something called the type of param. This is going to be what we're up to for basically the next section. This and methods. When we think about all of our data types and the functions that we've written, if we start to layer in the idea of methods and operators, we can start to do some serious manipulation and, let's say, interact with in a more complicated fashion with the inputs of our functions. Keep in mind, though, everything that we're about to do is going to be building on what we've been doing so far. If you've been having trouble, maybe go back and do the lessons again, but at the same time, it's not that big of a problem to go on to the next lessons and come back to these if you're having trouble. Our ability to kind of like build on what we've been up to, which is we write functions that solve very small issues, and then those issues are going to grow, but we're basically doing the same thing over and over again. So that's all for this unit. In the next unit, as we discussed, we're going to be talking about operators and methods and how they apply to all of the different data types we've gone over so far. So I hope you're enjoying these videos. Thanks for watching, and we'll see you in the next one.